Hi everyone, I'm Fikri. Before we go deeper about this topic, let me explain a little bit about differentiation and related rate. Stay tuned, okay? Now, let's look what is differentiation. Differentiation is the process of finding the derivative or rate of change of a function. It's useful when to find a rate of something and determine a function increasing or decreasing. Some of the application of differentiation is related rates and the maximum and the minimum problems. Our presentation will be focused on the related rates. Alright, now let's move to the related rates. Related rates use a basic derivative of differentiation for the algebraic functions. It involves writing an equation relating two variables, then taking derivative of equation with respect to the time. Then, it involves two or more variables that change at the same time and change at the different rates. For example, if we have x, it will be dx over dt. Second, if we have y, it will be dy over dt. To solve related rates problems, we can choose either chain rule or implicit differentiation. Now, let's take a look at a few steps to solve related rates questions, where these steps will be very useful for you to help solve differentiation questions that involves rate of change. So, in general, there are at least 5 steps that you need to follow to find the final answer to any rate of change question. So let's go through every step accordingly. So step 1, you need to draw a diagram if possible to get the entire picture of the question. Next, step 2, you need to gather all the information from the problem. Step 3, find any equation or formula that is suitable to the question and try to find any missing information. Step 4, differentiate the equation with respect to t, which is time. And lastly, step 5, substitute the value to get the final answer. Now that you have gone through every step, let's try out an example, shall we?
Now, let's go through a sample question to test our understanding of the topic. Here is the problem statement. A ladder 10 meter long leans against a wall in a building. When the lower end of the ladder is pulled away from the wall, the top of the ladder will fall down to the floor. If the top of the ladder will fall down at a rate of 4 meters per second, what is the rate of the lower end of the ladder moving away from the wall when the lower end of the ladder is 8 meters from the wall? For the objective, the question wants us to find the rate of the lower end of the ladder moving away from the wall when the lower end of the ladder is 8 meters from the wall. So our objective here is to find what is dx over dt when x is equal to 8 meters. So for step 1, we need to draw a diagram. From the problem statement, we can imagine that a ladder is leaned against a wall, which means that it is in diagonal state. So we can draw a triangle to represent the problem. In this diagram, y represents the wall, x represents the lower end of the ladder, and the thick black line represents the ladder itself, which is 10 meters. Step 2, gathering the information from the statement. So here are the information we can get from the problem. L refers to the length of the ladder, which is 10 meters. X represents the lower end of the ladder, which is 8 meters. We also know that the rate of the ladder falling down the wall is 8 meter. So now, the missing information is y, which is the height of the wall, and also the rate of the lower end of the ladder moving away from the wall, which is dx over dt. Step 3, we need to find a suitable equation. Since this is a triangle, we need to use Pythagoras theorem and its equation, which is a squared plus b squared equal to c squared. So in this problem, we can write it as x squared plus y squared equal to 10 squared. Next step, we need to differentiate the equation. Differentiate the equation with respect to d over dt. Since we are differentiating it with respect to d over dt, we need to multiply the derivative of all the terms with the derivatives of itself. For example, in this equation, the derivative for x squared is 2x, and don't forget to multiply it with dx over dt. The same goes to all the terms in the equation, and finally, we will get the derivative for the equation, which is 2x times dx over dt plus 2y times dy over dt is equal to 0. The final step to do is to substitute the value in our equation. Now that we have all the information, substitute the variable with the value and we will get the final answer. So in this equation, replace x with 8, y with 6, and dy over dt with negative 4. Solve it and we will get the final answer, which is 3 meter per second.
To summarize, the rate of change of the lower end of the ladder that is moving away from the wall is 3 meters per second. Plus, we have learned how to apply other formulas like Pythagoras theorem in differentiation. So this means that it is important to understand how the formulas are related with the given equations in order to get the answer by differentiation. So now that we know what is the application of differentiation and how to solve questions of related rates, we hope that you will find this video useful in your examinations and in your daily lives. So we've reached the end of the video. Thank you for watching and we'll see you guys next time. Bye bye.